All right, well, welcome. In this video, we're going to be starting a brand new unit dealing with conics. Now, this is something you've never seen before. Now, some of the terminology you've seen before, like you can see that we're going to be talking about parabolas here today in this video. But as a whole, this is, even with parabolas, this is going to be a new formula that you've never seen before, a new equation for a parabola. And let's start by just talking about what the heck is a conic. So when you look at this next slide, basically imagine if you had like a broomstick. So if you were holding a broomstick and put your hand at the center and started spinning it around really fast where the top and bottom was forming a perfect circle, you'd get what's called a conic. Basically just think of it as two cones that are facing each other like we have in that image there. But imagine again, it's that cone is formed, or those two cones are formed from a single line being spun around a fixed point. And if we were to start to take some slices into that conic, you would get these different shapes. So you can see from the first one, if you were to take and slice it where the slice would intersect the base there, and if you were to pull it apart, the shape that would be left from that slice would be a parabola. Now, if you were to do like in the middle, or the second image there, second diagram, if you were to take and slice parallel to the base, it would be another circle. Because remember, this broomstick or whatever you're spinning around, you were spinning it around in the shape of a circle on the top and bottom. So if you were to slice it in the middle or parallel, it would be looking like a circle. Now, if we were to tilt that slice slightly where it didn't intersect a base, but it was just tilted slightly, you might think that the shape looked like an oval. That's just another name for an ellipse. And if you were to do a slice that would intersect both bases, that's going to be the shape of a hyperbola. Now we're going to be breaking this unit down into three sections: parabolas, ellipses, and hyperbolas. A circle is very similar to an ellipse, but we don't talk about that. We just focus right now about, if we had more time, we would focus more on circles, but we're just focusing on parabolas, ellipses, and hyperbolas for the purpose of this unit. So let's talk more about parabolas. Now there is an activity that we did in class. If you weren't here, don't worry, we're just going to skip that. All right. But the purpose of this is for you to see that when we're dealing with parabolas, you're familiar with the term vertex. Okay, that you're familiar with. But you'll see a couple of terms here that are brand new to you. This idea of a focus and a directrix. Now the focus is a point that's inside of our parabola, and a directrix is a line that's outside of our parabola. And technically, if you look at this definition here, the points that create a parabola are all equidistant between the focus and the directrix. So if we created a parabola, we'd pick a point on that line, and if we knew where the focus is and the directrix, if we measured those distances would be the same. And that was the purpose of the activity, so it's too bad that we missed you in class, so you couldn't do that activity. All right, so let's look at this diagram. So this box might look really confusing, but I'm trying to break this down for you. So these first two columns are dealing with this equation, because you're familiar with parabolas that open up and upwards and downwards. We've seen those before. Okay, so when we're dealing with parabolas that open upwards and downwards, we're dealing with conics, we can use this equation. So it'd be x minus h squared equals either a positive or negative value for 4p, and then y minus k. Okay, so that's how you can think of these first two equations are based on, or these first two are based on this first one. So if our value for 4p, if it's positive, the parabola is going to be open upwards. If the parabola, or if the 4p value is negative, it's going to open downwards. And again, just to point out, so all the other equations that you've been dealing with all year, think about a standard equation for a parabola: ax squared plus bx plus c. So the standard equation, ax squared, so it's the x that's being squared. So for these first two columns, it's the x values that's being squared. So that's how you know that it's going to open upwards or downwards. So now let's skip over to this other side. So now if it's the y that's being squared, and the x that's just stays an x, if it's the y terms that are being squared, then that's going to be one of these unique ones where it's going to open right or left. Now if you notice, this is not a function because it fails a vertical line test, but we can still have an equation for it. So if the 4p is positive, the standard is it's going to open to the right. If the 4p is negative, then it's going to flip horizontally and it's going to open to the left. All right, let's go back to talking about one that opens upwards or downwards. Then if it opens upwards or downwards, our axis of symmetry is always x equals h. So it's going to be focused on that. But the key here is where the focus, and we didn't mention the vertex, by the way. The vertex we would take, it's just h and k, just like we've seen before. So you get that from the original equation, your vertex. So all of these, by the way, are focused, it says it over here, all of these are focused on the coordinate having a focus of h and k. So think of it this way, if it's opening upwards or downwards, the h value is going to stay the same because it's opening vertically, upwards or downwards. So the k value is what's going to change. So what's this p? So to find out our p value again is based on this. Okay, we got to figure out what p is. We'll talk about that in just a second when we look at an example. But we would take whatever that p value is, it would be k plus p would be our focus, or k minus p if it's opening downwards. The directrix can be below the vertex, so it would be k minus p. Or if it's opening downwards, the directrix is going to be above it, so it would be k plus p. And the same thing is true if it's opening right or left. Our focus would be inside the parabola, so it would be to the right of the vertex if it's opening to the right. So then our focus would be h plus p because it's to the right of the vertex and it's horizontal. And our directrix, since it's going to be vertex this time, it'd be x equals, not y equals, h minus p, because again, the directrix would be to the left of our vertex. Or in this case, the directrix would be to the right, so it'd be h plus p. And your focus would be inside your parabola, so it'll be h minus p. All right, let's look at an actual example here to make sense of all this. All right, so the first thing that I recognize, the first thing that I notice with this example is that it's the y value that's being squared. So if it's the y value that's being squared, this is one of those that's going to open left or right. So since it's the y value that's being squared, we know it's going to open left or right. Now, if our p value here was positive, it opened to the right, but since it's negative, it's going to open to the left. Okay, so that's important. Even if it doesn't ask for that, you always want to look to see if it opens left or right, because that's going to help us when we go to find these other values. Now, for this one, it might be easier to just sketch a graph. Okay, so let's think about where that would be. Let me put some dash marks here. All right, so we know it's going to open to the left, and the vertex is going to be the coordinate hk. So our h value, again, is what happens with the x. So we take the opposite of what happens with the x. So we have x minus 1, so the opposite of that would be a positive 1. And then our k values with our y. So we take the opposite of what's happening with the y, so that would be negative 5. So 1, negative 5. I need to go a little lower here. So 1, 2, 3, 4, 5. That's where our vertex would be. And I also know it's going to open to the left. So it's going to look something like that. All right. So now we want to figure out, well, what's our coordinate for the focus and the directrix. In order to find that out, we need to find out what our p value is. So since this -4, or since our value there out front is negative, I'm going to set that up to a negative 4p. So if I divide both sides by -4, I get p is positive 1. So that means our focus is going to be 1 unit to the left, because it's going to be inside, to the left of our vertex. So that's going to be at the coordinate where x is 0, y is -5. And our directrix is going to be 1 unit to the right. So it would be an equation, so it's going to be a vertical line. Whoops, it's going to be a vertical line, so it would be x equals 2, would be our equation for our directrix. So for these, it's easier to sketch a graph as you're doing it, so that'll help you figure out where these different values would be. But once you find out what direction it opens, then we want to find out our p value. So between those two, you can get everything that you need. So I want you guys to try this next one completely on your own. So go ahead and pause this video and hit play when you're ready to check your answer. All right, so for this one, we can see that it's the x that's being squared. So again, we know that if that's the case, it's going to either open up or down. The fact that our p-value is positive means that it's going to open upwards. So the graph opens up, and then you can see our vertex is going to be at positive 5 and negative 2. Then to find our p-value, since that 20 is positive, we would say 20 equals 4p, or 4p equals 20, same thing. Divide both sides by 4, and you get your p-value of 5. And once you know that, we can graph everything so we can find where our focus and directrix would be. So if our vertex would be at 5, negative 2, we would go 5 units up to find our focus coordinate. So that'd be the coordinate 5, 3 then, and we go 5 units down to find our directrix. Now it's a horizontal line, so it'd be y equals negative 7. All right. What if we have an equation, though, that's written like this? Doesn't look like anything like we saw the previous one. The only way that we can solve this is by going back, or not the only way, but the easiest way that we can solve this is by going back to what we learned about earlier this year, and that's how to complete the square. So let's review how to do that. So I want to get the squared term and any other terms that are the same as that one on one side of the equation, and then anything that's not squared on the other side. So our squared term in this is y. So we're going to have y squared, and we're going to keep the 2y with it. And then on the other side, I want to get rid of what's not related to the y, which would be the 4x and the minus 12. So I'm going to subtract 4x from both sides, and I would add 12 to both sides. Now there is going to be something that we're going to add to both sides to complete the square. Now remember, in order to complete the square, we want to make sure that the y squared term doesn't have a number attached to it, just a plain old 1. And if that's the case, or go to the next step, which would be to actually complete the square. So how do we do that? Whoops. Well, first off, oops, I'm getting too far ahead of myself. Then what we're going to do next, we're going to take our b value, which is this negative 2. We're going to take half of that and square it. So I want to make sure you see that that's a square, not times 2. Let me do that. There we go. So we're going to take half of b and square it. So half of negative 2 is negative 1, and when we square that, that becomes a positive 1. And so that's what we're going to add to both sides. And so to complete the square on the left side, what we're going to do is we're going to just take whatever half of b is. They're not going to square it this time. We just take half of b, so that way we get the sign correct. So half of negative 2 is negative 1. So we'd have y minus 1 quantity squared on the left, and on the right we'd have negative 4x plus 13. Now if you notice, if we compare this, what we have right now, to what we had in the other examples, the right side doesn't quite look right to where, well, how we want it to look. So if you notice all the other examples that we did, even with this one, we always had a number outside the parentheses, and then the x value didn't have a number attached to it. The last step with the one that we're working on, get to it, here we go, is we want to get that negative 4, we want to get that out of that x. And so we're going to factor that out. So the y minus 1 quantity squared stays the same, but I'm going to factor out a negative 4. Now when I do that, I know it's going to look weird. Negative 4 divided by negative 4 would be a positive 1, so we just have 1x. But then 13 divided by negative 4 would be a negative, and then we're just going to leave it as negative 13/4. So sometimes you'll have fractions, and that's okay. And so then if you wanted to, you could go through and find the focus, directrix, and vertex for this, but I would just want to make sure that you know how to come up with the equation. So we're not going to take the time to do that. You can look back at the previous examples if you want to find out how to do that. Or if you want to practice this, you can. But I want you guys to go ahead and get this equation written in that proper form. So go ahead and pause this video and hit play when you're ready to check your answer. All right, let's see how you did. So for this first part, again, to complete the square, this case, just like the previous one, the y squared is, or the y is the one that's being squared, so we'd want to keep that on the left side. So y squared plus 2y would keep on the left, but the minus 6x, you'd add that to both sides and subtract 13 from both sides, so you get what I have in there in green. Then to complete the square, we take half of b, so half of 2 and square it, so half of 2 is 1. 1 squared is just 1. So you add 1 to both sides, so now on the right side, you'd get 6x minus 12. On the left, to complete the square, you take half of your b value now, but you don't square it. Half of 2 is just 1. So you get y plus 1 quantity squared equals 6x minus 12. But we don't want that 6 in front of the x, so I factor that out. And so when you do that, you get y plus 1 quantity squared equals 6 times x minus 2. And again, if you wanted to pause this video and try to get the rest of these values now, you could. Otherwise, for right now, I just wanted to make sure that you knew how to get that equation written in that proper form so you could easily find the vertex, focus, and directrix. All right, so hopefully you have a better understanding now of what a conic is all about, and specifically today, what a parabola is from a conic. And good luck now as you work on your assignment.